Okay, so welcome back. Now, a couple of things I want to go over. In the last example, we used the test for symmetry to see whether it was symmetric with respect to the line pi over 2, the polar axis, or the pole. But we have to also consider the fact that if you remember sine is an odd function, right? So the sine of negative theta is equal to the negative of sine theta, and cosine is an even function where cosine of negative theta is equal to just cosine of theta. And so the reason why I bring that up is it is important to realize that the test for symmetry in polar coordinates that we listed in the previous video are sufficient to guarantee symmetry, but a graph may have symmetry and not pass the tests, those tests. Okay? For example, this equation does not pass the tests. And in fact, it will fail to reveal the symmetry. Now, it is symmetric, and you could show this by plotting it. It is symmetric with respect to the line pi over 2. Okay? Because if you replace, if you make the replacements, neither of the replacements will satisfy, will work out. Okay, so that brings us to what I have on the board right now. Okay, so if we do these replacements here, look what we get. We get r equals negative theta plus 3 pi. We get negative r equals negative theta plus 2 pi. And so, so neither one of those gives us the original equation back, right? And so in the last example, in the checkpoint, that's what happens because you're dealing with sine, right? You're dealing with the equation r equals 4 sine theta that we did in example 1, right? But also note that it's a function, r is a function of sine theta. And its graph is symmetric with respect to the line pi over 2. And also the equation r equals 3 plus 2 cosine theta that we did in the last example is a function of cosine theta, and its graph is symmetric with respect to the polar axis. Okay, so then what we could do is this will help us determine quick tests for symmetry by understanding that whether it's a function of sine or a function of cosine. And we'll do that next.